everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a bar for its tensile test. We will use the explicit dynamics module for analyzing. We will start by double-clicking on explicit dynamics. We will first go to engineering data. Engineering data sources. I'll double click on explicit materials. The material which I'll use is steel. So I'll choose steel 1006 as the material. So once you've selected the material, you can see there's a bookmark over here. We'll go to project and update project. Next, I'll go to geometry and right click. New design modular geometry. We'll go to units, millimeter, XY plane, look at. I'll go to sketching. I'll use the line option. First, I'll draw a straight line. Then I'll draw a vertical line. From here, I'll draw another horizontal line. Then an inclined one. Again, a horizontal line. And then I'll replicate with an inclined line, a horizontal line. And from here, I'll draw a vertical line. I'll go to modify and choose the trim option. I'll remove these extra lines. Then I'll go to dimensions and give dimension to these lines. Also, I'll go to vertical and choose the distance between these two lines. And horizontal option I'll use for giving the distance between these 2 points. So we will start with say V2. The diameter of the rod, we are making a cylindrical rod. So this is say 20. V6 is symmetric, so this is also 20. V7 is 12. Next I'll go to H1. The total length of the rod will be 500 mm, that is 50 centimeter. I'll give the value of H4 as 200. I'll give the value of H3 as 100. H5 as 50. H5 is 100 and H8 is 50. So you can see here the shape has been created. Now I'll go to modeling. Here I'll choose revolve. I'll select the sketch 1. Axis is the central one. Apply. It's a 360-degree turn that will take and generate. So this is the bar for which we are going to analyze. So now I'll close this. Next I'll go to model and double click. I'll first go to geometry and change the material for this solid to steel 1006. Next I'll go to mesh. I'll give the value of element size as 0.01 meter and generate. Now I'll right click over here and I'll insert method. I'll select the entire geometry. I'll give this as tetrahedrons and generate once again. Now I'll go to analysis settings. You can see here there is a question mark. It is asking for the time. So I'll give the time as 0.001 second. Then I'll go to explicit dynamics, right click, insert, fix support. Now if you have observed the analysis of the tensile test, one end is fixed and on the other end there is a displacement which is given. So what I'll do is I will select this face. I'll press Ctrl and select the other one. I'll click on apply. This is fixed. Next I'll select these two sides by pressing the Ctrl button, and I will right click here and insert displacement. Along the x axis I'll give the displacement as, I'll select unit as mm. This is 140. Then I'll go to solution and right click and I'll insert stress equivalent. Then I'll insert strain equivalent plastic. Also I can see the deformation total. You can see any other deformation if you want. Then I'll go to solution and solve. So once you get the solution, first thing you will do is go to equivalent stress. You can see here the deformation is caused. So we can just animate and check the result. You can see the formation of, this is the cone formation, this is the cup formation, and you can see how the necking is formed in this red zone. The diameter reduces and then slowly there is a breaking of the material. Here you can see this is the elastic limit, after which the plastic zone is going to start. Hence you see a increase and then there is a variation of value. We can also see the plastic strain here. Again you can see here there is a straight zone and then there is variation in the value. You can see what is the total deformation. We have given 140 mm such that we are able to break the bar and get the values. So that's how you analyze with the help of this material steel. If you want, you can change the material to any other variety of steel and get the results. If you don't want to see these meshes, you can go to edge, no wireframe, and if you analyze now, you will see there is no wireframe on it. Here also if you want, you can change it to smooth contours such that the colors blend into each other. And here you can see slowly the diameter is reducing. This is the necking phenomena which is expected in tensile test. And then you can see the breaking of the material. So this is one of the shape of the tensile test material which is used for this test. There is one more variety of material. I will show the analysis in the next session. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.